Hi, my name is Kevin, the founder of the TEALS program, and welcome to the TEALS volunteer info session for the 2016-17 school year, where you can find out how to help high schools across the country build and grow their CS program, and at the same time, keep your day job. So let's start with some statistics. According to the Bureau of Labor Statistics and the National Science Foundation, there's going to be 1 million unfilled jobs that needs a CS background before the decade is out. And if they're not filled, it represents a $500 billion loss to our economy. That's something like 3% of annual GDP. And this is not just a problem for the private sector, but think about national defense. They also have a huge shortage of computer scientists. And this slide is about 2 years old. The data on this slide is about 2 years old. And that number is much higher now in terms of billions of dollars of lost opportunities. And in addition, every computer science job that is filled, 6 more jobs are created in the economy. So let's look a little bit further back into college. Everyone can read pie charts, so I'll let you take a look at this. Sadly, it's not one of those hilarious meme charts, but I'll let the huge discrepancy of college students in STEM, which isn't already an area where students are undersubscribing, to the percentage of STEM graduates that's needed in computer science. Just let that chart sink in for just a second for you there. So if we go even further back, let's take a look at high school. And that's where the problem really is. The graph here shows the number of AP exams taken in 2015. AP is advanced placement, so it's the college level course that students take at the high school level. It is the tip of the iceberg. If you look at English or calculus, you sort of see the overall health at the end of that high school pipeline. Let's look at computer science on the spectrum. This is a huge problem. Computer science is way at the wrong end of that chart. We are about 1% of overall AP exams, and you can take a look at the other STEM exams like physics, bio, stat, chem. That's where we should really be. Except we've been stuck between art and art history for over a decade now. We are really behind. The good news is that the number of CS exams grew by 25% in 2014, but we haven't moved past art yet. And that's where we really need to be, is triple or quadruple our numbers at the 200,000 range. And of that 46,000, TEALS actually represents 3.5% of that national number. In 2016, computer science isn't just about programming. Computer science and the ideas in computer science permeates the students' lives. And the key to a thriving democracy is to have informed citizens. And as big issues like surveillance, privacy, big data, AI, digital crime, digital currency, all of these come out, our high school students that are graduating now have to have a basic literate understanding of all of these big ideas in computer science. That's one tier. Another tier, computational thinking and the big ideas in computer science that enables all of these things. And whatever the students end up majoring in STEM, in healthcare, in education, in sports, whatever it is, understanding the big ideas in computer science will be a crucial tool for them to be successful in their future careers. And third of all, yes, computer science, we do want some kids to major in computer science. We want to teach computer science just for the exact same reason people teach bio, chem, physics. Not everyone needs to be a doctor or a chemist, but having that basic level understanding, able to understand the big ideas and apply it to whatever other field they end up in. And third, if some kids end up in that field, fantastic. For the exact same reason, we need to make sure that computer science is taught at every high school across the country. So let's look at what computer science in every high school actually means. There are about 42,000 high schools across the United Sea, from sea to shining sea. 3/4 of them do not offer any sort of computer science. What that means is every year there's 3 million high school seniors that are graduating without ever having the opportunity to take a computer science class. I'm not even saying it's mandatory, it's just the fact that computer science is an option for them to check on their class list. I think that's absolutely unacceptable in the United States, but sadly, it is what's happening on the ground. Things are changing in the 25 states in the union now recognize computer science as a math or science credit. It was 9 when TEALS first started in 2009. Code.org, ACM, Microsoft, and a lot of other tech companies has teamed up to make these policy level changes. However, just because there's policy and law changes doesn't mean there's actually computer science on the ground. As Tip O'Neill said, all politics is local, and so is education. Just having a law passed doesn't get you computer science in the classroom. A lot of people think that if you're in a state, especially at a state where there's a lot of tech and tech companies, there would be a ton of computer science education. And actually, that is not the case. This is the best case. Washington State, where TEALS has been around for 6 years, where half of the AP computer science exams are from TEALS schools. We're the only state where the percentage of AP CS exams as a percentage of total AP exams is above 2%. And this is the best case. And if you look at statistics about underrepresented minorities, African American students, Hispanic students, female students, they're all far below what the representative population looks like in the state. We showed you Washington, so now let's look at my home state where I grew up, and that is California. And much bigger state, 8th biggest economy in the world, a lot of tech companies everywhere. But if you look, the percentage of AP CS exams as a percentage of AP exams total is actually lower than Washington State. And you can look, the percentage of girls and African American students taking the AP exam is actually lower as well. We really need to fix this problem. If you think this is just a West Coast problem, this is actually a nationwide problem. Take a look at Georgia, Ohio, North Dakota, New York, very representative of the rest of the country in terms of computer science education. This is fundamentally a problem of lack of computer science teachers. This is a picture of the MIT Computer Science Career Fair. As you can see, lots of demand for computer scientists, and it is incredibly difficult for schools and high school to compete with industry and government. As you can see, all of the swag that companies give away, Facebook, Google, Boeing, Square, Yelp, and you can see the NSA is in there as well. And if you have a EECS or CS degree, you could probably not have to do your laundry for a long time. What you don't see in that picture are high schools. They're not at the career fairs. Incredibly expensive to be there, and as a CS graduate, or all college graduates, graduate about, I think, on an average of $30,000 in student debt. It is very difficult for them to choose to go into teaching when everyone is coming at you with a lot of offers and opportunities. And as a result of schools unable to compete for CS talent, they're unable to have computer science teachers in the classroom. And without computer science teachers, they will not put a computer science course in the course selection sheet for the students. And there's no students, there's no demand. And sadly, over the past decade, there's actually fewer computer science classes in our high schools. Now let's imagine you're a teacher at a high school that wants to teach French, but no one in the school speaks French. So this is what it is like from the teacher's point of view when the principal tells them they're going to be teaching computer science, but we'll substitute French in here for a second. Your principal wants to have an AP French class. you don't speak a single word of French, maybe had some French fries before, or know what a Peugeot is, but your principal says, hey, you know what? I'm going to send you to the College Board AP French training over the summer. It's a week long. Actually, it's really 4 days long, but that's enough, right? You would be able to teach AP French. And sadly, for computer science, that is exactly what's going on. It doesn't make sense for French, and it doesn't make sense for computer science. Now, imagine the principal also said, hey, you know what? Instead of you learning French, AP French in 4 days, I have 4 native French speakers. They are going to teach the class with you. You're going to learn from them. And once you get the hang of French from these native French speakers, you're going to be able to teach AP French on your own after a couple years. Now, to the teacher's ears and any sane person, this seems much better than just 4 days of a College Board AP French workshop. Just as no one can learn college level French in a week, neither can anyone learn computer science in a week. But we make it safe for the teachers and schools to offer it and take that very vital first step with them. And this is why our teachers and school love TEALS. This is our model. TEALS works with high schools that are committed to offering computer science but don't have any teachers on staff with a CS background. And we work with them to build a sustainable computer science program with the help of volunteers like yourself. First period, so 7 to 8 or 8 to 9, before you're actually needed at work. And after a while, the computer science teacher that you'll be working with is able to teach computer science on their own. And this involves everybody, the tech community, the school administration, the principal, the classroom teacher. It really, as it turns out, takes a village to build a computer science program. And we offer AP CS and Introduction to Computer Science, which we'll talk a little bit more in depth about later. As software engineers and computer scientists, we see all of these advances made in MOOCs, massive online classes going on, and say, hey, why don't we do it that way? Let's just sit a student in front of a computer and they'll learn computer science. This is absolutely not true. Look at the difference having a classroom teacher teaching computer science versus a student studying alone. As the material gets harder, it absolutely makes a huge difference of how students learn computer science, their achievement levels, and also you get a lot more girls learning computer science if there's a classroom teacher versus them being alone in front of a computer. We absolutely believe that classroom teachers are the ones who will make a difference in computer science education. We actually have a great proven model, and as LeVar Burton in Reading Rainbow usually say, but you don't have to take my word for it. As promised earlier, now we're going to talk about what we actually teach our students. We teach our students rigorous computer science. So the very first course we introduced them to is the UC Berkeley CS10 course that we worked with the Berkeley CS department to adapt it for high school kids. It's a semester-long course, and we teach it back to back with 2 sets of different kids. And think of it as a survey class like conceptual physics or bio. You get to learn a little bit about everything, but it's not as deep. But you still get all of the big ideas. This is a block-based programming language, so you can see they do everything that AP Computer Science do, but they don't have to worry about syntax. And this is a course that has great reception at UC Berkeley. It was funded by the National Science Foundation and has a great track record of introducing students of all different backgrounds to computer science. Well, the other class we teach is your typical first semester college level computer science class for CS majors. In this case, we use the University of Washington CSE 142 and 143 courses, so things like everything including OOP and recursion and all the other cool stuff that you remember from your very first semester of computer science at the college level. It's a year-long class, and we use actually Java, and you can see in the picture where we're using Eclipse, and you get all of the upperclassmen, sophomore, juniors, and seniors, and we're using the very standard building Java programs from University of Washington for this course as well. You might have heard about this in on the internet or through another source, but there is a new AP course called AP CS Principles, and we'll be doing some pilots with Berkeley as well as code.org and maybe some other organizations. Think of this as, if AP CSA that we just looked at is Calculus BC, this would be Calculus AB. This is the CS class for non-majors, and very much like our intro class, but at the AP level and that amount of work. And we'll be piloting this with a small cohort of schools in different regions. The TEALS co-teaching model is our primary support model that we use, especially for schools that do not have a pre-existing computer science program and a teacher who does not have a pre-existing background in computer science. For the co-teaching model to work, there are two essential pieces forming one team: the volunteers and the classroom teacher. The classroom teacher is someone who is committed to learning and teaching computer science down the road, an experienced teacher who's got a few years of teaching under their belt. They're committed with the school to go to summer professional development, and for case of AP, many of them come in with experience of teaching an AP Science or AP Math previously. And the volunteer team is, combined with the classroom teacher, is really a team of 5 together, including the classroom teacher. The volunteer team is split into teacher and TA roles. Most first period classes are done by 9:30 or so, and each of the teacher and TA paired together are in the classroom 2 days a week. Some folks do week on, week off, but usually a lot of people do Monday, Tuesday with one teacher, one volunteer teacher, and one TA, and then the Thursday, Friday, the other half of the team. The TA role here is, helping out during lab, one-on-one help with students, do some of the grading, and the teacher role is a superset of that. They do everything that TA do, but in addition, also do lesson planning, course planning, and delivering the course content itself. TEALS also has 2 other models that are more appropriate for teachers that have an existing background in computer science or have gone through, a couple years of partnership with TEALS already. We have the TA model, where the teacher is able to teach computer science on their own, and we're really there for helping run lab and bringing industry experience into the classroom and be a technical backstop for the classroom teacher, and possibly also help with guest speaking or anything else that may come up, or a topic where the teacher may need some help. And the third model that we have is for classroom teacher who are able to completely teach computer science on their own, and they want to be part of the TEALS community, but they may not need the in-class support, but they do want an industry mentor, someone to meet up with them offline, not during school hours, for an hour a week to help them do lesson planning, work through some of the harder problems with them. And for both of these models, unlike the previous co-teaching model, volunteers are also getting their travel expenses reimbursed, but instead of $5,000 split 4 ways, this is where the schools will set up something that does, let's say, for example, mileage reimbursement. Now that we've seen the details of the 3 different support models for TEALS, let's look at this graphical summary that helps us to see the big picture. On the left, we have the various responsibility associated with running a high school CS class. We can see that the expectation of our program is that the teacher, the classroom teacher, is leading the classroom and doing classroom management from the very beginning, the partnership. However, the other categories, volunteers are very much taking a majority of the responsibilities at first, but then very slowly passing them on to the teacher over time as the teacher feels more comfortable with all of those duties included in teaching. And by the time they're in the consulting support model, the last one, they're no longer leaning on volunteer support day to day in the classroom. In order to do this, it is a big, big commitment. We are in the classroom day in, day out, and we're with the classroom teacher and the students throughout the entire school year. So this is like joining a gym for a year, except if you don't show up, we're not teaching computer science that day. So it's a huge, huge, extraordinary commitment. And we have a breakdown of a pie chart for you, but total commitment is about 280 hours. If you take a look, we have calculated the commute hours for you if you make a detour on your way to work. You can see there's training, summer training. We have 3 weekend sessions for you for summer training, and there's work that you need to do with your team together to prep for the school year itself. There's meetup and team meetings that we added some more hours. The actual teaching hours are about 80 or so hours. There's 36 weeks in the school year. So you times that by 2 days a week, about 70, 80 visits to the classes themselves. And so you have 80 hours there, and we've also prepared that for every hour that you spend in the classroom, that there's an equal amount of time that you're going to be prepping and grading for the class. So that all adds up to a very big commitment of 280 hours. But you do get to do this amazing thing of teaching high school computer science and help a school build up a program. But once again, the commitment is very, very large. Think about it, talk to your family, talk to your manager at work, significant other, pets, whoever this life may impact. And you do get to make a huge impact. Look at who we are teaching. If a school wants to offer computer science, we are there. We work with public schools, public charter schools, private school, religious school, independent schools, all sorts of different schools in all sorts of different settings, and high performing school, high need schools, and any and everything in between. If you've seen a high school, we probably have worked with a high school that's very, very similar. And the diversity of our student comes from the schools that we partner with. Almost 1/3 of our students are girls, which is double the industry average. 20% of our students are underrepresented minorities. 93% of our students want to go to college. And of those, 70% of them, as this is their first CS class of any sort. And we would definitely want to prepare them to go into college having a CS class under their belt. And we do this in the school day because it is so incredibly important that students that play an after-school sport or participate in band or volunteer or do academic groups after school have the chance to take the CS class not as a club, but as a real class where they get grades from. And one thing that TEALS does is work with high schools in rural communities where there's not really a pool of computer science industry volunteers, and it's 2 hours from the nearest metro area. So we actually teach these rural high schools using teleconference technology and volunteers. You can see Michael there in his office putting on a tie, and teleconference and screen share and work with students in rural areas just like anywhere else. And this year we will have about 25 schools working with us from rural areas teaching computer science with us. And we're one of very, very few programs that actively goes out and work with schools in remote areas, because kids in rural areas deserves a chance to take computer science as much as anyone else. Our program not only just helps teachers and schools build a sustainable computer science program, but also helps build a lot of excitement around computer science and bringing the students and the teachers into the computer science and tech communities. Our volunteers provide industry connections, whether it is talks or bringing their colleagues from work or other companies or friends from college to talk about what they do now, and also things like we have huge field trips where students, high school CS students, go and meet with local companies, local colleges, and see if they keep on continue with computer science, where they will end up. And what does all of this work really translate to? Well, it translates to approximately 90% of the classroom teachers that work with us are on track to teach on their own. And teachers and students say 90% of them say that volunteers were helpful in them learning computer science. 80% of our students at the end of the course feel proficient in a programming language. These are all incredibly high numbers in education. And for AP Computer Science this year, we scored once again above the national average, and historically we have always scored around 8 to 14% above the national average depending on the year. And look what our volunteers from across the industry have done. We have combined put in close to 500,000 volunteer hours invested in our schools. We have taught 17,000 students computer science. We've had 14,000 volunteers come through the program. We've taught 6,500 AP CS students. And if you put all of those hours together, if we do the thing that law firms do with their pro bono work, all of the hours we put in at industry consulting rates, we are talking about well over $100 million in equivalent services that our volunteers have donated and invested into the schools that we work with. This is the map of the schools that we're going to work with for the upcoming school year. We're going to be working with about 275 schools in 23 states. So if you have friends in any of those states that are computer science folks, please let them know about this as well. Well, you might want to ask, how did this crazy thing ever get started in the first place? Well, it started in 2009 when I was a software engineer in Office 365. A local high school found out that I used to teach high school computer science in the past, and I worked out a deal with them where I would come in and teach first period and then go to work. So I was essentially volunteer zero, and they really liked this model because I had previously taught computer science for a few years down in the Bay Area after graduating with a CS degree, and then went to grad school and then ended up working at Microsoft. So it was very natural for the local school and me to figure out, hey, you know what? I don't have to go be at work until 10 o'clock, so I can go and teach a period of computer science. And before that semester is out, 4 more local schools heard about this. And so what I did was I recruited a few friends, I trained them over the summer, and this is the very first cohort you can see there at Issaquah High School at the time. And then the program just sort of snowballed out of there. We went from 1 school to 4 to 13 to 35 and 100 volunteers. And then I realized I couldn't just do this in my spare time being a software engineer in Office 365 and work with 100 volunteers and 35 schools. I really just had no time to do this. And I was going to spin this off as a 501c3. I sold my Porsche, I had my resignation letter, and because it's really worth doing, and nobody was doing that. And my VP at the time heard about this and said, hold on, before you quit, let's go see Satya. I'll take you to go see Satya, who was not CEO back then. He was the president of Server Tools and Business. And in the meeting, essentially, we figured that if I do this as a nonprofit, I will spend 80% of my time raising money and very little time actually concentrate on the program itself. So Satya proposed that Microsoft hosts and incubate the program as long as makes sense. I don't have to ask people for money. We can just work on the program itself. And I just ask Microsoft Philanthropies for a budget, and it's kind of great. I get to do both. I have the resources of Microsoft and Microsoft Philanthropies and keep doing what we've been doing. And what we do is so incredibly important to not just Microsoft, but the entire tech community and the country. And the tech community has given so much to Microsoft, and it is incredibly important for Microsoft to give back to the tech community in a real meaningful way. And that's why Microsoft Philanthropies is supporting us and supporting every engineer that wants to do this, no matter who signs your paycheck. The funny thing is we're probably the only organization in Microsoft that actively goes out and teach Java. And it's really amazing to have Microsoft Philanthropies embrace this program, and even more importantly, have the support of the entire CS and tech community to embrace this program. And that's why 3/4 of our volunteers are folks from companies that are not Microsoft, and to have that level of support is absolutely incredible. And this is a picture of just how far we come in the past 7 years with the number of schools, the number of students that we've taught, the number of volunteers, and this is all because of our volunteers have really embraced this program. And this is a program really built by engineers and teachers for teachers and engineers. So if you really care about education and computer science education and you have a CS background, whether that was your major, minor, or you learned it on the job, we have 550 volunteers from across the country representing over 200 companies volunteering with us this school year. And for the upcoming 2016-2017 school year, we'd love to have you join the team and volunteer with us as well. Different folks have very different reasons for why they want to volunteer with us and give back to the tech community. So I'll let you read this. This picture is of Chris Callahan, one of our volunteers, and he is teaching at Juanita High School in Kirkland. Computer science education is something that we have to fix and get right in the next few years. It's been my life's work even before I graduated in electrical engineering, computer science, teaching robotics camp, and then after graduation, teaching at local high school, going to graduate school for it. And even when I started working in the tech sector as a software engineer, I still try to find ways to continue and teach, and that's how TEALS got started. And now we have this grassroots movement for software engineers to give back in a meaningful way. And I really hope that you will consider joining us in this movement. And if you do end up volunteering with us, whether it's 1 year or multiple years like many of our volunteers have, at the end of the day, you're leaving a legacy at a school. You're not just volunteering there for that 1 year, and once you leave, that program is gone. You have trained a classroom teacher, you have built multiple CS classes, and you would have left a sustainable computer science program with TEALS at whatever high school that you're volunteering at, and build up a CS program where there was none before, and really be a role model and inspire the next generation of EE and CS majors to build that next big thing. And at the end of the day, for a lot of students, what that means is that you're actually changing their life trajectories and really change their lives. This is a big, big commitment. And so you've heard the session, go onto the website and take a look at our other volunteer materials. Go talk to people in your life, and if that's something you want to do and commit yourself, if so, you need to apply by May 2nd. Then you'll be interviewed by our regional managers in the schools together, and you'll be placed on a team in the first week of June, and then we will do that weekend, the 3 weekend training sessions, 3 Saturdays really, and train you to be ready for the classroom over the summer, and then you're ready to teach. So that's what the timeline looks like for the starting from now. Once again, thank you for spending the time with me online and watching this info session. And think about if you want to apply, we'd love to have you join us.